All right, we're going to do some sample questions from polar parametric test. Again, just hitting the ones that probably were some of the harder problems to do. Let's take a look at, let's write this out first. Polar parametric test. And we're going to take a look at problem number 2 to start off with. Instructions here are to give a coterminal polar coordinate. All right, so that means that we will be given a polar coordinate, and then we will write a corresponding coterminal position, which is exactly the same position, of course, as this is, except in a different with different values. Potentially changing the sign of the 7, and of course potentially changing the position. So this is r theta. All right, let's see where that is first. We'll start off with a little picture of it. So if I'm going to choose we call this a directional distance or directed distance, because as you have probably seen from the videos that you've watched, it is possible to write this as a negative value, even though we know that radius is not negative. We can give an ordered pair with a directed distance value that's negative. So if I do start here at this -7 position, and I rotate from that position, if I rotate -pi/3, that's going to be clockwise. And that's going to put me right here. Okay. So this would be the point that we're working with. All right, that would be -7, -pi/3. And another way to write that, we're going to do 2 different ways here. We're going to do a +7, and we're going to do a -7. All right, as directed distance radii. So if I were to go to +7, start at this position instead of the -7 directed distance, then if I start here at +7 and I rotate as far as I need to get to this position, that rotation, of course, is counterclockwise, so it's going to be a positive angle measure. And if I simply subtract pi minus pi/3, then that's going to give me 2pi/3. So this would be 2pi/3. Okay. So there's one way to write a coterminal position. We'll do another one with a -7. That means I'm going to stick with this -7 directed distance, and we're going to rotate all the way around, all the way back around to go until we get to that position again. Okay. So if I start here at the -7 directed distance and I rotate all the way, that's going to be 2pi minus pi/3. We can write that here, 2pi minus pi/3, and that's going to be 6pi/3 minus pi/3, which is 5pi/3. And we are rotating counterclockwise. All right, so that is going to be a positive angle measure, positive 5pi/3. All right. All right, let's pick up with problem number 4. This says convert to polar coordinate form. So 4, convert to polar coordinate form. And what we're looking at here is a given rectangular coordinate for number 4 of √6, -√2. Okay, this is an x and a y instead of an r and a theta because it's in a rectangular form. I'm going to write that as rectangular or Cartesian. You saw that probably in some of the videos that we looked at. Rectangular or Cartesian form is what this is, and we're going to translate that into polar coordinate form. Our 2 formulas that we're going to be using here in order to convert it would be r² = x² + y². And the formula tan theta is equal to y over x. All right, these two formulas will help us to convert this over to polar coordinate form. So r squared equals, and we're going to do x squared as 6 and y squared as 2. So r squared equals 8 and r equals root 8. Now we're going to stick with the positive root 8 for right now, the directed distance of positive instead of negative. We're going to go ahead and just give 1 point. All right, that works for this one. Root 8, of course, is also the same thing as, if we take out that 4, 2 root 2. Okay. But we're still going to stick with that positive value. So now let's do tangent. Tangent theta equals y over x. In this case, that's going to be negative root 2 over negative root 6. And if we just kind of take this through its paces, oh, sorry, that's positive. That's going to be a negative 1 over root 3. Okay. I could put it all underneath the radical if I needed to, but that's also the same thing as a negative root 3 over 3. So we're looking at where on the unit circle is the tangent equal to negative root 3 over 3. And we're going to stick for the moment, in order to write one ordered pair in polar coordinate form, we're going to stick with that range that you learned back with inverse tangent. Of course, there could be many solutions for a trig equation. For rotations, if we put it in the calculator, we're going to see that thing go up and down, and there could be several different places, but we're going to stick with the restricted range for inverse tangent, just to write one ordered pair to make it nice for us. Okay, so in this particular case, this position right here is going to be where the tangent is equal to negative square root of 3 over 3. That does happen to be, for our purposes, that is going to be a negative pi over 6. Okay. And so we can put these two things together now, and we can write this ordered pair as 2 root 2 comma and negative pi over 6. All right, a couple of things. This is an r, this is a theta. This is one specific point. We need to be able to check it to make sure it's the same as this one. All right, so if I look in terms of quadrants here for this ordered pair in rectangular form, I will be able to see that it is in positive square root of 6 negative is going to put me right about in here somewhere. Okay, positive, negative, here and here. All right, root 6, negative root 2, that's going to put me in the quadrant 4. All right, now just check to make sure that this one is also in quadrant 4. And as we saw with our rotated value, if I go approximately 2 square root of 2, distance of 2 square root of 2, and then a rotation of negative pi over 6, it's going to put me in that exact same position. All right, let's take a look at conversion going the other direction. So this, I'm going to do number 5 with you here. So number 5, we're going to convert to rectangular form, and that means we're going to be using the other formulas that you were referred to in the video that you watched. So we're going to be given the ordered pair for number 5 of 2 comma 7 pi over 6. That is r theta. All right, that is in polar form. And our two conversion formulas are nice ones this time. X equals r cosine theta and y equals r sine theta. Okay. So we'll simply be plugging these into those two positions and finding them on the unit circle. So first, let's determine the quadrant that this is going to be in. I'm just going to take a moment to kind of find it. Positive 2 is directional distance. We'll consider that positive 2. All right, and then we're going to rotate 7 pi over 6. Well, let's say this would be pi, or 6 pi over 6 of this position would be 7 pi over 6. Okay, so we're just going to check that as we go. And we're looking for filling in some values here. X equals 2 times cosine of 7 pi over 6. And we'll do the same thing for the other equation. 2 times sine 7 pi over 6. And then we simply need to find the values for cosine and sine of 7 pi over 6. Well, it just so happens that we have 7 pi over 6 here already. So let's write out our two our order pair for the two values is going to be negative root 3 over 2 negative 1/2, and that's cosine sine. So let's fill these in. X equals 2 times, and negative square root of 3 over 2 comes from here. And for y, we get 2 times negative 1/2. And that gives us, when we reduce, x equals negative square root of 3 and y equals negative 1. Okay, let's look at that answer and make sure everything looks right. We can check it. So negative square root of 3, negative 1. Remember that this has to be in the same quadrant as the polar coordinate. This is x and y. So let's just real quickly sketch that out and find out if it is. All right, so here's my negative square root of 3, which we'll put right about in here since that's a little more than negative 1, and then negative 1, we'll put that right about here. And sure enough, that gives me the point negative square root of 3, negative 1 in quadrant 2, just like we checked with in the original problem. So there's my answer for converting that coordinate. All right, let's look at one that is converting rectangular equations. We'll take a look at problem number 8. And the given problem is r equals 1 over 1 minus cosine theta. All right, so we're going to translate this from what is obviously polar equation form into rectangular equation form. So convert into rectangular equation form. All right, so lots of forms that can take. We'll talk about those as we go. What I want to be able to do here is to cross multiply. There's several different methods here. One of the worksheets that I gave you several methods for converting rectangular equations. This is one of those methods. Cross multiplying, so we get r minus r cosine theta equals 1. We start looking for some of those conversions that we're familiar with, such as x is equal to r cosine theta and y is equal to r sine theta. We'll use this one in this case. So r minus x equals 1. We want to isolate the r so that we can further simplify it. R equals x plus 1. And we're going to square both sides in order to turn this into another familiar form. R squared equals x squared plus y squared. And that means we're going to be squaring both sides, and that gives me r squared is equal to, go ahead and, you don't have to do this, you could leave it like it is, but we'll go ahead and multiply it out so you can see the whole process. X squared plus 2x plus 1. And now we know that r squared is equal to x squared plus y squared, so we can simply substitute it. And then we'll start simplifying the equation. So if I subtract x squareds, they disappear. Y squared equals 2x plus 1. And if I want to get x by itself, to put this into x equals y squared form, then I'll simply move the 1 across to the other side. Y squared minus 1 equals 2x, and then divide by 2 to get x equals 1/2 times y squared minus 1. Now, we said there's lots of forms that this can come in. We're just going to stick with this one for the moment, and we'll stop at that point right there. And let's do a couple more in this section, then we'll just make this one of 2 parts. Let's take a look at number 9. All right, this one is converting theta equals 7 pi over 4 into rectangular form. So all of these are converting into rectangular form. In this particular case, I'm going to take the tangent of both sides because of the nature of the problem. I know I can find the tangent of 7 pi over 4, and I know that tangent theta, using my formulas again, is equal to y over x. So I now have y over x is equal to, we'll find 7 pi over 4. All right, here's my position of 7 pi over 4. 1, 2, 3, 4, 5, 6, 7. And that value is negative 1. The tangent value is negative 1 at that point. So negative 1. And then we want to get y by itself if we can. So we multiply by x, and y is equal to negative x. That takes care of that one. Last one we'll do here before we end this section, this first section, is problem number 10. We're looking at r equals 2 over cosine theta minus sine theta. All right, we're going to employ another one of the tactics that we have talked about before, and this is kind of a familiar one. It's cross multiplying. So that gives me r cosine theta minus r sine theta is equal to 2. And this is a nice one because r cosine theta, of course, is equal to x. And r cosine theta is equal to y. We saw that up here earlier. All right, so x minus y equals 2. And again, we'll try to get y by itself. Negative y equals negative x plus 2. Change all your signs, and y equals x minus 2. Okay.